So far, we've looked at sequences and series and wrote rules by determining what the pattern was. Then you learned what an arithmetic sequence is, which is when there's a constant difference between each term. So you're always adding or subtracting the same number every single time. And the rule for that ended up being a sub n equals a sub 1 plus n minus 1 times d, where d is the common difference. The geometric sequence will be whenever you're constantly multiplying or dividing by the same thing. And the division really just ends up being multiplying by a fraction. That fraction is going to be our common ratio. So the ratio of any term to the previous term would be constant. An example of a ratio would be doing the second term over the first term. So the second term over the previous term. You could also do the third term over the second, the fourth over the third, the fifth over the fourth, so on and so forth. There is a general rule that we could use, which would look like this, saying a sub 1 multiplied by the ratio that's raised to the power of n minus 1. So that n minus 1 power only belongs to the ratio. For example 1, we're going to identify whether or not each sequence is geometric or arithmetic. But if it's neither, we may still try writing the rule if there is a pattern. This brings us back to what we were doing in 9.1 and 9.2. So for A, we're going to start right here. The first thing I'm going to do is see if it has a difference. So what am I adding or subtracting? To get from 8 to 12, you would be adding a value, excuse me, you'd be adding a value of 4. Now, to go from here to here, you would be adding a value of 6. From here to here, I would add a value of 9. So there is no constant number for what I am adding, meaning this is not a difference and it is not an arithmetic sequence. A ratio would be a term divided by the previous term. So I actually have to start with the second term. So going from here to here, I'd put the second term, 12, over the first term, 8. And then to go from here to here, I would do 18 over 12. From here to here, I would do 27 over 12. Now, if you leave it like this, it could be hard to tell if it is a ratio or not, meaning that it's always constant. They have the same fraction each time. So you would actually have to simplify it. Both 12 and 8 are divisible by 4. So this becomes 3 over 2. 18 and 12, those are both divisible by 6. So that would become 3 over 2. Same thing here, when I simplify 27 over 12, I get 3 over 2. Oops, I meant to say 27 over 18. I get 3 over 2. And the term they were both divisible by was 9. So because this fraction is constant, we would say yes, it is a geometric sequence where the ratio is 3 over 2. Part B, we're going to check for difference first. To get from 8 to 16, I would add 8. To get from 16 to 24, I would add 8. 24 to 32, I would add 8. So I'm adding the same number every single time, meaning that it is an arithmetic sequence. Part C. Let's try a difference first. Going from 6 to 10, I would add 4. But from 10 to 15, I'd add 5. From 15 to 21, I would add 6. Because this is not constant, it would not be an arithmetic sequence. For a ratio, remember you take a term and put it over the previous term. So 10 over 6, 15 over 10, 21 over 15. And we'd simplify it. So 10 over 6, both of those are divisible by 2. 15 over 10, both are divisible by 5. And honestly, I could stop here. I don't even have to simplify the next one because I can see that these fractions are not the same. So that does not have a ratio, meaning it's not geometric. So it's neither. I'd like you to pause the video and try D, E, and F. Hit play when you're ready to check. For D, it was geometric, where the ratio is 1/3. When you're writing the ratios of the previous terms, for example, I'll do the first pair, you had 1/12 over 1/4. You could either plug that in your calculator or remember that it's keep, change, flip when you divide fractions. So it's 1/12, you keep the first term, change from division to multiplication, and flip the bottom. That gives me 4 over 12, which is 1/3. I do the same thing here for 1 over 36 divided by 1 over 12. You do keep, change, flip. You would get 36 over 12. You would get 12 over 36, which would give you 1/3 as well. So it is constant. It keeps giving you a ratio of 1/3, which is why I was geometric. Here you're constantly subtracting 0.4, so you need to make sure that your difference is a negative 0.4, meaning it's an arithmetic sequence. And then F is neither, because you didn't constantly add the same number and the ratios were not all the same. Once you identify a pattern, you could keep applying that pattern until you get to a desired term. But let's say I wanted to know what is the 500th term in this sequence. You don't want to do this 500 times. It would be helpful to have a rule that you could just plug it into in order to find the term. So we're going to show you how to use a general equation to find an nth term. And in this case, I would like to find the 9th term of the geometric sequence. So first off, the directions tell me, hey, this is geometric. So I know it's geometric, which means to get the ratio, I just put a term over its previous term, which gives me a -2. So I know that R is 2. Now for the equation, I'll write general equation. I have A sub n equals A sub 1 is the first term. So my first term was a -5, meaning I'm going to put a -5. And I'm going to multiply that by the the ratio, which is -2. And I'm going to raise the ratio to the power of n minus 1. So in the general equation, you leave it in terms of n, which is what I've done here. And we're plugging in the ratio and the first term. Now I want to know what is the 9th term. So what is A sub 9? Well, if I have a sub n and I want to find a sub 9, I just have to plug in a 9 wherever I see n. So this becomes negative 5 times negative 2 to the power of 9 minus 1, which gives me negative 5 to the negative times negative 2 to the 8th power. This 8th power only belongs to the negative 2. And when you're plugging it into your calculator, you need to make sure that you put parentheses around the negative 2. That way the negative is included. So it would look like this. Parenthesis, negative 2, close your parenthesis, to the power of 8. I get 256. So I have negative 5 times 256. Last step is just to multiply by negative 5, meaning the final answer is negative 1,280. Let's do another one. For part B, I know it's geometric, so I need to find the ratio, putting my term over the previous term. So I'm usually going to do the second term over the first term. It just makes it easier if I'm consistent about it. If I were to plug that into my calculator, 0.01 divided by 0.001, you can see I get 10. So the ratio is 10. Now I'm going to write my general rule, which is a sub n equals my first term, which is 0.001, times my ratio, which is 10, to the n minus 1 power. So that's my general equation. I want to know what is the 9th term. So I want a sub 9. That just means I'm going to plug in 9 for n. Giving me 10 to the 8th power. Remember, the 8th power only belongs to the 10, so I'm going to plug that in my calculator. 10 to the power of 8 is a really big number. I'm going to multiply that really big number by 0.001. So my final answer is 100,000. Next, we have part C. Why don't you go ahead and pause the video and attempt to find the answer. For part C, you should have first found your ratio. I usually do the second term over the first term, so 12 over 3 gave me 4. Then I use the general equation, which is this, and I would plug in my first term and my ratio. So the general equation is a sub n equals 3 times 4 to the n minus 1 power. Using this general equation, I wanted to find the 9th term, so I'm going to find a sub 9, meaning I plug in 9 where I see n. That gives me 3 times 4 to the 8th power. First thing I did was I found out what 4 to the 8th power was, which was this large number right here, and I multiplied that by 3 to give me my final answer.